I'm Anil Kumar, and in this video we will learn how to write equation of high degree polynomial from the graph. So we'll take example with a nonic polynomial. Nonic polynomial means degree is 9, right? So in this case degree is 9. Let me sketch one, and then we will find possible equations of that graph, right? Now, to give a complete example, what I will do is I'll take different kinds of zeros. Let me take one which is like this. That means you understand it is odd degree, right? And then let me take a zero which is kind of okay, let's go through origin like this. And this is a quadratic zero, or you can say even degree zero, and then we'll take a linear zero, right? So these are different kinds of zeros which we are considering for this particular nonic polynomial. Now if I do like this, it is not going to be a nonic polynomial, right? Since nonic is odd degree, if we start from here and end up in this place, then it has to be an even degree. So I have to introduce another zero here. So let me have another zero close by, which is again a linear zero. Okay, so let me connect some lines to make a polynomial with the help of smooth lines. So that forms kind of a graph for us, right? Connecting the zeros. And let's say we go up from there, and then we go like this. Now this becomes odd degree function, so we can now say this could be a nonic polynomial, right? So let us write down possible equations for this function. So we are saying this is x, and we have f of x, and we need to find possible equations for f of x. This is origin. Let us say this point is -4 for us, where we have a 0 here. This point, let it be at 4, and this be at 5. Okay, so what we have here is 1, 2, 3, 4 zeros. Now the first zero is kind of cubic, right? So 3 plus 2 gives us 5, 6, 7. Well, that gives us degree of only 7. We are looking for nonic polynomial degree 9. It means this could be actually of degree 4, correct? Only then we can make it degree 9. We could also do, if we make this as 5, 6, 7, 8, 9, that is also possible, right? So we can write a couple of possible equations for this graph, right? So one of the equations could be f of x equals to a times, kind of necessary to write a, since there could be many graphs going through these zeros with the given characteristics, right? Now, so the first zero will give me a factor of x plus 4, and for the first time we'll take an equation where this is cubic, so we'll have 3 here. The second one is at 0, so x minus 0 is x, and since we want degree of 9, we decided we'll make it 4, not 2, right? So it could be 2, 4, 6, right? So we'll take it 4. And then we have two linear zeros. Straight lines are linear. So we have factors of x minus 4 and x minus 5. So if you see this polynomial, in that case, we have degree 1, 2, and 4, 6, and 3, 9. So that could be a nonic polynomial, correct? As we discussed, we could also write an equation f of x equals to a times. We could consider this to be of degree 5. It's flat enough, right? So we could write this as x plus 4 to the power of 5. In that case, we'll keep this as square. And then we have these two factors. Correct? So these are possible equations for the given graph where the degree of the polynomial is 9. Now these both of them are general equations, but in case we are given a point on the graph, right? If we are given a point on the graph, let us say we are given a point here which is, let's say, 1 1. Let me write this point as 1 1. Okay, so we are given a point 1 1 on the graph. In that case, we can always find value of a, and then we'll know specifically what is the equation of the graph, right? So I'll leave that for you to calculate, but what we can do here is, let me show you what. Let me show you for the first equation, you do it for the next one. What I'm trying to say is that we have a point 1 1 on the graph, right? So that means f of 1 should be 1, right? So we can write f of 1, which should be 1, and in this, so we are using the first equation. As a practice, you should find exact equation for the second one, right? Now, 1, and if x is 1, in that case, a times 1 plus 4 is 5, so we get 5 cubed, and then we have 1 to the power of 4, right? So, and then we have 1 minus 4, which is minus 3, and 1 minus 5, which is minus 4, right? Now you can use the calculator. Let me hold on calculator and then find the value of a, right? So a in this case will be, these two will get multiplied and you'll get positive values. So we get 1 equals to 5 cube is 125. So let me use the calculator. So we have 5 cube, which is equals to 125 times 3 times 4 times 12, that is equals to 1500. So we have 1500 a here, right? Now, so from here we know the value of a is equals to 1 over 1500, correct? 1 over 1500. And therefore, our function f of x is equals to 1 over 1500 times x plus 4 cube, x to the power of 4, x minus 4, x minus 5. So that becomes a specific function if we know the point, right? So x value of 1 was placed here, right? And f of x plus 1 was placed there to find the value of a, right? So we get one possible Nonic polynomial, degree 9, 1, 2, and 4, 6, and 3, 9, which will satisfy this particular graph. Now I hope you understand with this a couple of things. One, nature of 0. If we have a turn like this which flattens out, it represents odd multiplicity of a function at that point. So odd multiplicity of the 0 at that point for the given function, right? And this is more than 1, so it could be 3, 5, 7, or so on. A turning is multiplicity of 2, 4, 6, even, right? A linear multiplicity if it crosses the graph in a straight line, correct? So that helps us to figure out a possible equation, and knowing a point will give us equation of specific graph. So now as an exercise, you can find equation if we have a 5 degree of multiplicity of 5 at minus 4 for the 0 at minus 4. Okay, I hope with this you understand and appreciate how to find equation of a polynomial from any given graph. Thank you and all the best.